black holes. They are mysterious and kind of scary. In the next few videos, we're going to talk about the idea of a black hole, the idea of approaching and entering a black hole, and also what happens when you actually travel closer to the speed of light, what you would actually be doing when you try to enter a black hole. This is What the Math, and welcome. Enjoy the video. And so first, let's actually use Space Engine because it does allow you to create this very beautiful lensing effect, and because it actually has a black hole at the center of our galaxy that I've showed you how to reach in one of the previous videos that you can then explore in more detail. It's a supermassive black hole. In reality, it's about 4.1 million masses of sun, but this one here is only about, I think, 2 million. It's not as realistic, but that's okay. We'll forgive it. And the cool thing about this particular black hole is that it actually has several stars orbiting around it. Specifically, I think it's like 23 stars. And so we'll actually get to see some of the effects of approaching a black hole. But before I jumped into this black hole, let's actually define the ideas that we need to know about this. And specifically, let's actually define the idea of frame of reference. When you talk about black holes, you have to always consider the effects of general relativity. And here we're talking about the idea of the reference point. So there's actually two reference points when you're talking, or when you jump into a black hole. There's a reference point from the outside, where, you know, you're basically somewhere, let's just say on this star right here. And this is a star where one of your twins live. Let's just say your twin is Antonia, your sister, or my sister in that case. And then Anton, the adventurer, will actually try to enter the black hole. So you are somewhere around this system, and you're basically looking at what happens to Anton, your adventurer's brother, that tries to get inside of this scary looking dot in the middle. And of course, the second frame of reference is that of Anton. That is actually the reference where we are going to be flying inside of this black hole. So basically, we're going inside of it. And before your twin brother Anton actually lands or goes inside this black hole, let's actually debunk some of the myths about them. And I think the biggest myth here is that black holes are black. That's not entirely true, because they do emit something. They emit something called Hawking radiation. So technically, there is a way to detect them. They also emit some other things like very low frequency radiation from all of the objects that actually do reach event horizon. And so there is a way to detect them, but just because they're so far away from us, it's very difficult for us to do directly. And misconception number 2 about black holes is that they are like vacuum cleaners. They suck everything into them. And that's not really true either, because just like stars, just like planets, they create gravitational effects. They basically bend space and time to such an effect that things kind of fall into them if they're too close, but they don't really suck anything in. If you were in a spaceship and if you were basically just using your engines, you would basically be able to, and if your spaceship is obviously very powerful, you would be able to easily just float above it. It's not going to suck anything in, just like a planet or a star wouldn't either. So you can technically orbit around black holes just like you would around normal star, but there is a point around black holes after which the actual orbit becomes kind of very difficult to achieve, especially if it's a very massive black hole. But we'll talk more about this later. And the myth number 3, I guess, would be not really a myth, but just misconception about black holes in general. I think most people think that, you know, as soon as you basically approach a black hole, you die. Well, that's not entirely true. First of all, it depends on the black hole size. And ironically, if it's a small black hole, if I were to look out there, and actually I do have some small black holes here already, if I were to go to one of these smaller black holes that I've discovered, like for example this one right here that also doesn't really have a name but just is called RS something. So this black hole right here is relatively small. Its mass is about 8 masses of the sun. And so if I were to actually try to approach this black hole at a distance about this much, this is when the effects of gravity on me would be so high that I would actually be spaghettified. Here's a picture of what spaghettification looks like. Basically, the gravitational effects on, let's just say, the top of my head versus the top of, or the bottom of my feet would be so strong that I would be stretched into spaghetti, my atoms would be stretched, and I would eventually just die. A horrible stretchy death. That's of course if a black hole is small, and this would happen way before I would even reach the so-called event horizon that you see right here. Now what about a large or mega super massive black hole like I was showing you in the beginning? A supermassive black hole, like the one in the center of our galaxy, would actually not have a similar effect. As a matter of fact, you can easily approach the event horizon, and you can even pass the event horizon without nothing really major happening to you. Okay, that's not entirely true. Something would happen to you, but nothing that would kill you. And that's actually where things get really interesting. So let's actually just take the frame of reference of Anton the Adventurer first, and we're going to try to enter the black hole. So let's just say you're in a spaceship and you're slowly approaching it. As soon as you start approaching it, you will start noticing really interesting things. Everything in front of you would start getting blue shifted. Basically, things would get more blue and blue, and I'll demonstrate this to you in the next video where I show you how blue shift looks. If I were to turn around, everything would be red shifted. It would start getting dimmer and dimmer and dimmer and dimmer and would become more red. And the other interesting thing about the approach toward the black hole is that, well, you obviously would see things getting bent just like you see here, and time around you would actually start to accelerate. You would start seeing things moving a little bit faster. I mean, increasing the time scale, and you'll actually get to see how some of it looks in a second. Now, this actually is better demonstrated by this video I'm showing you right now, and I posted the link where you can find a lot of these really cool simulations that are very realistic. So this is what the actual approach would look like to a realistic black hole that has spin and has charge, and you actually get to see particles flying around it. Now, so the time around you would accelerate slowly, and you would actually not feel any different. You would not feel any spaghettification, you would not feel even a headache probably. You would just feel normal. Nothing would really change for you. And you can see the time has actually accelerated. We get to see the stars moving around us really, really fast. And you can kind of see them in the background as well as their light bends around us. And basically the time would increase. It would accelerate even more. It would accelerate even more. Unfortunately, Space Engine doesn't demonstrate the other star motion, and I'm going to use Universe Sandbox 2 for that, just to give you an even better impression of what happens when you enter the black hole. But basically, at some point, right before you cross the event horizon, the time will move so fast that you will see everything moving in fast forward. Everyone you have known would already have been dead a long time, and the entire galaxy would start changing shapes and possibly get absorbed by the black hole, or possibly would collapse into some other galaxy. And at some point you'll cross the event horizon and you get to see the entire universe in front of you just end. You would literally see the end of the universe and would enter the black hole. Now, what happens next, I'm going to talk about in the future. But for now, enjoy this view of this beautiful black hole in Space Engine, and watch out for the video that's going to be out tomorrow, continuing this exploration, where you'll get to learn what happens when you're inside the black hole. Don't forget to subscribe, don't forget to share and like this video, and watch out for the next part. Thank you so much for watching, game you later, bye bye.